Hello students, let us continue the session on pair of linear equations in two variables. In the previous session we had learned how to represent a given pair of linear equations on graph, and also we have seen the three conditions. First condition was two lines they intersect each other, they will have a unique solution. The second condition was the two lines they coincide each other having infinitely many number of solutions. And the third condition was two lines they run parallel to each other which has got no solution. Let us solve a question related to graph. The question is, solve graphically the following system of linear equations: 3x plus y plus 1 equal to 0, 2x minus 3y plus 8 equal to 0. Shade the area of the region bounded by the lines and x-axis. Recall how we had drawn the graph for pair of linear equations. We had taken the equations separately. We found the coordinates of x and y for both the equations. Then we had plotted the graph. Let's continue the same thing. I'll take the first equation, 3x plus y plus 1 equal to 0. From this equation, y will be minus of 3x plus 1. Let us make a tabular column and find the values of x and y. I have found the value of y for three different values of x. When x is minus 2, the value of y is 5. When it is 1, the value of y is minus 4. When it is minus 1, the value of y is 2. For the second equation, 2x minus 3y plus 8 equal to 0, y value will be 2x plus 8 upon 3. The x and y coordinates, when the value of x is 2, the value of y becomes 4. For x equal to 5, y becomes 6. For x equal to minus 1, y becomes 2. Now with this information, we have to plot the graph. I'll take the graph paper. I'll consider x and y axis. The equation was 3x plus 1 equal to 0, and we had made tabular column having the coordinates. Let us plot these coordinates. Minus 2 comma 5, it's in the second quadrant. 1 comma minus 4 is there in the fourth quadrant. Minus 1 comma 2, again it is there in the second quadrant. Now with these 3 points, I will draw a line passing through these 3 points. This is the line. So we had represented 3x plus y plus 1 equal to 0. Now let us take the second equation, 2x minus 3y plus 8 equal to 0. The tabular column, I'll take it. Now I'll plot the coordinates 2 comma 4, it's in the first quadrant. 5 comma 6, again it is in the first quadrant. Minus 1 comma 2, which is there already in the previous line. Let me plot a line passing through these 3 new coordinates. You can very well observe these 2 lines, they are intersected at minus 1 comma 2. This minus 1 comma 2 is the common solution for both the lines, both the equations. In the question, they had asked to shade the region between the two lines and the x-axis. This is the region. I have drawn lines there. So we can say that the two straight lines are intersected at minus 1, 2, and minus 1, 2 is the common solution. Now I want you to solve a question. Try solve the following system of linear equations graphically. 2x plus y equal to 6, x minus 2y plus 2 equal to 0. Find the vertices of the triangle formed by the above lines and the x-axis. Also find area of the triangle. I will give you an hint by taking the previous graph. You can see there is a triangle formed here. Let me show you that. Yes. Let me name these points. Let me name this as A, as B, and this as C. Now these vertices A, B, C are the vertices of the triangle. To find the area, you know that area is half base into height. In other words, area is half multiplied to base in this figure is BC, and the height we do not know, we need to find. Height is the perpendicular. Suppose from A, if you draw a perpendicular on BC, we get the height. If you can measure this distance of A from this particular point, let me name this as B, AD length is 2 units, so H is 2 units. BC, from here to here you measure the distance, BC length. With this length of BC and the length of height, we can find the area. Area will be 2 multiplied to whatever BC length was there into 1 by 2, half base into height. This is how we have to solve in the next question. Let us take up one more question, not related to graph. Find the value of P for which the pair of linear equations 2px plus 3y equal to 7, 2x plus y equal to 6 has exactly one solution. We have learned in our previous discussion, when the coefficient ratios considered a1 upon a2 shouldn't be equal to b1 upon b2. For this condition, we have pair of linear equations having exactly one solution. Let me find out what is a1 upon a2. For these two equations, a1 upon a2 is 2p upon 2. 2 will get cancelled, you get only p. Let me find out b1 upon b2. b1 is 3 upon b2 is 1, so we get the value of b1 by b2 as 3. And c1 upon c2 is 7 upon 6. When we take this 7 to the left hand side, minus 7, 6 to the left hand side, minus 6, and the ratio minus 7 upon minus 6 is same as 6. Since a1 upon a2 shouldn't be equal to b1 upon b2, there will be exactly one solution for which p shouldn't be equal to 3. So we can conclude, hence there will be exactly one solution for all values of p except 3. Let us solve one more important question. Find the values of alpha and beta on which the pair of linear equations 2x plus 3y equal to 7, 2 alpha x plus alpha plus beta times y equal to 28 has infinite number of solutions. We need to consider this infinite number of solutions. For infinite number of solutions, we have the algebraic condition e1 upon e2 equal to e1 upon e2 is equal to e1 upon e2. Therefore, when I replace this e1, e2, e1, e2 with the actual coefficients and the constants, we will be getting 2 upon 2 times alpha equal to 3 upon alpha plus beta, which is equal to 7 upon 28. Now, how do we find alpha and alpha plus beta? We consider this first one along with the third one. Let me take 2 upon 2 alpha equal to 7 upon 28. Simplify this. 2 will be cancelled. 7 4 times is 28. We get 1 by alpha equal to 1 upon 4. Reciprocally, the alpha value is obtained as 4. Now to find the value of beta, either you can take the first two or the next two. Let me consider 3 upon alpha plus beta equal to 7 upon 28. 7 4 times is 28. We have found the value of alpha at 4, 4 beta equal to 1 upon 4. As multiplied with 12 equal to 4 plus beta. So the value of beta is positive 8. So the alpha value obtained is 4 and the beta value obtained is 8. Let us solve yet another question. Find the values of k. Will the following system of equations have infinitely many solutions? The equations are 2x plus 3y equal to 4 and k plus 2 times x plus 6y equal to 3k plus 2. They are given that the required condition is infinite number of solutions. So let me consider that condition. For infinite number of solutions, take a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. Now, as we had done in the last question, we will replace with the actual actual values of the constants and the coefficients. 2 upon k plus 2 equal to 3 upon 6, which is equal to 4 upon 3k plus 2. Let me consider the first two equalities. Let me consider this. Let's consider 2 upon k plus 2 equal to 3 upon 6. 3 2 times. Now we need to cross multiply to get 4 equal to k plus 2. So the value of k is 2. Suppose if you consider the next two, consider 3 upon 6 equal to 4 upon 3k plus 2. Once again, 3 2 times is 6. On cross multiplication, we get 3k plus 2 equal to 8. So 3k will be equal to 8 minus 2. The value of k is 6 upon 3, which is equal to 2. So by taking both the ways, we are getting the value of k as 2. Therefore, we conclude that for k equal to 2, the equations will have infinite number of solutions. Now we'll move on to another way of finding the solution of linear equations. That particular method is called as algebraic method. So we'll discuss algebraic methods of solving the square of linear equations in variables. There are three important algebraic methods. First method is method of substitution. The second method is elimination, and the third method is cross multiplication method. We'll discuss in detail some of the examples each of these methods. First, let me consider substitution method. I have taken two equations, pair of equations, x minus 7y plus 42 equal to 0, and one more equation here, x minus 3y minus 6 equal to 0. Let me solve this by the method of substitution. There are certain steps to be followed. First thing I will do is I will note these two equations with the number equation 1 and equation 2. Let me consider equation 2. In the equation 2, we have the value of x as x will be equal to, transpose the other terms to the right hand side, 6 plus 3y. Now we will substitute x is equal to 6 plus 3y in equation 1. We have taken equation 2, we have written x in terms of y, and we are replacing that by substituting in equation 1. So if I do that, x should be replaced with plus 3y minus 7y plus 42 equal to 0. Just simplify this equation. What will be 3y minus 7y is negative 4y. 6 added to 42 will be 48, When you transpose that to right hand side, it becomes negative 48. So the value of y is negative 48 upon negative 4. Just simplify, we get the value of y as positive 12. Now x is equal to 6 plus 3 times. Instead of y, we'll replace with the value of 12. X will be equal to 6 added to, what is 3 times 12? Yes, 36. 36 added to 6 is the value of x. Value is 42. Therefore, the solution is x comma y equal to 42 comma 12. There is no requirement that only the second equation should be taken and it should be substituted. The value of x should be substituted in the place of equation 1. There is no rule. You can consider the value of x from the first equation, then replace the second equation. Still, we get the same answer. In the next session, we shall solve some more questions related to the method of substitution, and we will learn how to solve by using elimination method and also cross multiplication.